In earlier lecture, we have solved the bar bending schedule problem for slab concreting, and now in this session we will solve one more problem of bar bending schedule for beam design. Myself, R.V. Zubdar, Assistant Professor in Civil Engineering Department, Shar Institute of Technology, College of Engineering. Following is the example for the beam in RCC design. Calculate the quantities of following items for beam shown in figure. Reinforced concrete 1:2:4 for beam. Formwork for beam. Weight of steel in kg. Prepare bar bending schedule and percentage of steel with respect to reinforced concrete. This diagram is showing detailing about the reinforcement, in which the in-twin span is given as 7 meters. The wall bearing thickness is 0.30 meter or zero point 0.3 meter or 300 mm, and depth of beam is 50 centimeter and width is 300 mm or zero point 0.3 meters. This shows the longitudinal section of beam. The beam is provided with top bars, bottom bars, and stirrups along with the bent up bars in it. These are some details of cross section of stirrups, which shows the bottom bars provided are 5 in numbers, top bars are 2 in numbers and having 2 bent ups. The following detailing is given. A is 20 mm 5 straight bar having 3 numbers at 2.5 kg per meter. B 16 mm 5 bent up bars 2 numbers at 1.6 kg per meter. C 16 mm 5 bent up bars 2 numbers at 1.6 kg per meter. D 12 mm 5 anchor bars 2 numbers at 0.89 kg per meter. E 10 mm 5 stirrups 10 centimeter center to center at 0.62 kg per meter. F 8 mm 5 stirrups at 15 centimeter center to center at 0.40 kg per meter. G 6 mm 5 stirrups at 21 centimeter center to center at 0.22 kg per meter, and H 20 mm 5 pins at 21 centimeter center to center at 20.25 kg per meter. Now for calculation of steel quantity, we have to put all these details in bar bending schedule format. The first column is item number, second is item description, third is number, fourth is length, fifth is breadth, sixth is unit weight or unit per meter, and last is quantity. Now the first item is reinforced concrete having proportion of 1:2:4 for beam. The beam concreting can be calculated by multiplying length, width, and breadth or depth. That is, L is equal to 7 plus zero point 0.3 plus zero point 0.3, it is equal to 7.6. Breadth is equal to 0.30 and height of beam is equal to 0.50 meters. The total number of beams given are 1 only. Therefore, the quantity of concrete can be calculated by multiplying 1 into 7.6 meter length into 0.30 meter breadth and 0.50 meter depth. It is equal to 1.14 meter cube. Formwork for beam. The formwork for beam are of three types, that is bottom formwork, side formwork and ends formwork. For bottom formworks, the total number of bottom is 1 and having dimension length of 7 meter, breadth of 0.3 meter, and the total quantity is multiplication of both, which gives 2.10 meter square. For sides, the total number of sides is 2, the length is 7.6, that is 7 plus 0.3 from both sides, and the unit weight or width is 0. 0.5. The total quantity for sides shuttering is equal to 7.60 meter square, and for ends, the end is having width of or breadth of 0.3 and depth of 0.5, and the total quantity of shuttering for ends required is 10 meter square. For calculating quantity of steel in kg, the first item is 20 bars or 20 high straight bars provided at bottom. The length can be calculated by adding 7 plus 0.3 from both sides plus 2 times hook length, that is 2 times 9d, that is 9 into 0.202, and minus cover from both sides, that is 2 into 0.05. The total length for this 20 bar is 7.86 meter. The total number of bars for one beam given are 3. Therefore, the total quantity of or total weight of bar required for 20 is 3 into 7.86, and total unit weight per meter is 0.25, which gives the total weight of 20 bar as 58.95 kg. Now the second type of bar is 20 5 pins provided to support the bars, having length of 0.3 minus 0.2 times 0.025, that is side cover. The total length is 0.25 meter. Number of pins required are equal to span divided by spacing plus 1, that is 7.6 minus 2 into 0.05 minus 2 into 1.8 plus 2 into 0.9, that is 2.1, divided by 0.21 plus 1, that is 11 numbers. The total quantity of pins required is equal to 11 into 0.25 into 2.5, that is equal to 6.88 kgs. The third item for reinforcement is 16 high bent up bars. These bars having straight length of 7.6 plus 2 into 9 into 0.016, that is hook length, minus 2 into cover from both sides, which gives the total straight line length 7.79. Total number of bars for beam given are 2 and having length of 8.16 by addition from of cover from both sides and deduction. Now the total number of 16 bars is the multiplication of 2 into 8.16 into 1.6 per meter weight, which gives the total weight of 26.11 kg. For beam, one more no, diameter of bar, that is 12 5 anchor bar is used. For calculating length of 12 5 anchor bar, L is equal to 7.6 plus 2 times 9 into 0.015, that is hook length, 9 times d, minus cover from both sides, that is 2 into 0.05. The length of 12 bar is 7.72. The total number of 12 bars used for beam are 2, and the total quantity of steel required is calculated by 2 into 7.72 into 0.89, that is 13.74 kg. Now 10 stirrups are calculated. For that, we have to find out the cutting length for a single stirrup. The cutting length can be calculated by A if A is width of stirrup, B is breadth of stirrup. Then A is equal to zero point 0.5 minus 2 times cover minus 2 times bar diameter, which is equal to 0.43 meters, and the width B is calculated by 0.3 minus 2 times cover from both sides minus 2 times bar diameter, that is equal to 0.23 meters, and length of stirrup is calculated by 2 times A plus B plus 24 times D, which is equal to 2 times 0.43 plus 0.23 plus 24 times 0.010, it is equal to 1.56 meters. The numbers of stirrup given is equal can be calculated by 2 into 1.8 divided by 0.1 plus 1, which is equal to 38 numbers. The total quantity of bars in kg required is can be calculated by multiplying number of stirrups, that is 38, into length of bar 1.56 multiplied by the weight per unit meter, that is 0.62, which gives the total weight of 36.75 kg. Now the next diameter of bar used for beam is 8 5 stirrups, which is equal to A is equal to 0.5 minus 2 times cover from both sides and minus 2 times bar diameter from both sides, and it is equal to 0.434, and B is 0.234. Now by calculating number of bars similarly as in earlier stirrup case, the total number of stirrups required are 12 The length of stirrup is 1.53. The unit weight per meter is 0.40, and total weight is multiplication of all these quantity will give the total weight of 10 bar is 7.34 kg. Now the last type of bar is 6 bar. The quantity of or number of stirrups calculated with the same formula as above, and the total number of 6 stirrups are 11, and the length of single stirrup is 1.50, and the unit weight per meter is 0.22. The multiplication of all these uh, values give the total weight of 6 bar required for single beam is 3.36 kg. Now entering these all values in bar bending schedule along with the shape of that particular bar. For 20 the shape is given, and the quantities which we have calculated are entered in the tabular form, that is 7.86 into 3 into 23.58 will give the total weight of 58.95. For bent up bars the total weight is 26.11. For C type 16 5 bar, the total weight is 26 kg. For D type 12 straight bar, the total weight as calculated is 13.74 kg. For 10 stirrups, the total weight of bar required is 36.75. For F type, that is 8 stirrups, the total weight of stirrups required is 7.34, and for 6 high stirrups the total weight required is 3.63, and for 20 pin bars or pin rods the total weight required is 6.88 kg. Therefore the total weight of bar can be calculated by adding all these weights in kg. Percentage of steel with respect to reinforced concrete can be calculated by volume of steel is equal to mass upon density, that is equal to 179.40 divided by density, that is 7850, which is equal to 0.0228 meter cube. The volume of concrete is equal to 1.14 meter cube. Percentage of steel can be calculated by volume of steel upon volume of concrete into 100, that is equal to 0.0228 divided by 1.14 into 100, that is 2%. Now this example is complicated example with heavily reinforced beam. Now for solving such kind of problems, we have to bifurcate first the type of steel bars provided for the particular component, and after the shapes and diameter of bar are bifurcated, then these shapes and diameter are entered into the bar bending schedule for easiness in the calculation of total weight of bar. Thank you.